if we can influence the way the kernel behaves, that's really powerful. And it gives us all sorts of interesting opportunities, particularly in things like networking and security and observability that we want to apply to all of our applications.
This is DevOps Paradox, episode number 217, Learning eBPF with Liz Rice. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farson. Victor, we've talked about eBPF a little bit here and there. We've had vendors on, such as Ground Cover and a few others. What do you think about eBPF now?
It's becoming a thing that very few understand, but everybody wants. I go at eBPF from a perspective, not necessarily I want eBPF, I don't want sidecar containers. That's my pitch towards eBPF. I don't really know what it is, but if it can remove my sidecar containers, it sounds like a great thing.
Well, if we could only ask somebody that knows about these kinds of details. Oh, wait. Today's show, we have Liz Rice on. She is the author of Learning eBPF. Seems like she might know something about eBPF. Liz, thanks for joining us today.
Thanks for having me. It's a pleasure to be here.
Now, Learning eBPF came out earlier in 2023, I believe, or late 2022.
It's we've had like online early release versions out towards the end of 2022, but the final printed copy landed in my hands in March this year. So it's not been out that long.
So that's good. So how many times have you already had to do a revision for it? Because it seems like eBPF keeps on just churning and churning.
It's a great question. I have had one error raised, so it wasn't too big a deal. I'm not too worried about that. I tried to write the book not to be like a reference that precisely reflects exactly where we are with eBPF today, because eBPF is changing and evolving. So I wanted to concentrate more on the concepts and a general idea of kind of the shape of it, if you like. And then I hope it will remain relevant for some time to come. I really didn't want to write a book that would be out of date before it was even published.
You mean like every technical book that exists in the world today?
Pretty much. I mean, it's hard to make them completely future-proof, but I think there's a lot of things that are fundamental concepts that won't necessarily change and that give people a good grounding, even if they come to it, hopefully in 2 or 3 years. And
that's the part about eBPF, because it's not a thing unto itself. It's grown out of Berkeley Packet Filtering, BPF. So for people, let's see if we can keep this to like 5 minutes. Can you give the history of eBPF? I already sort of led with BPF. Why does all this matter, right? And then we'll get into some more probably esoteric things that Victor will keep prodding on.
And before you answer it, I have an additional question. Why the heck is it called something that nobody can pronounce?
And also, I mean, really, that acronym is not very meaningful anymore. I quite often, when I'm talking about eBPF, I'll start by saying, it's extended Berkeley Packet Filter, but forget that because, it's got so little, it's so much more capable now than packet filtering that if you remember that, that's not terribly helpful. But it initially started as a way of being able to write programs that could make decisions about which network packets to filter. And there was a instruction set for these programs that run in a little sandbox, if you like, a software virtual machine inside the kernel. And then there was this idea that maybe we could use it for many more purposes than just filtering packets. And then the E came about largely because the instruction set was rewritten to be much more capable. And you can now attach these programs to pretty much any event that happens across not just the kernel, also user space, but mostly we attach to events in the kernel and run these custom programs in this sandbox environment. And we can use those programs to react to events, observe those events, and potentially even change the way the kernel is behaving. And that makes it super powerful. If we think about how the kernel is involved in everything that our applications do. So if we can influence the way the kernel behaves, that's really powerful. And it gives us all sorts of interesting opportunities, particularly in things like networking and security and observability that we want to apply to all of our applications. I don't know, did that describe both the history and the importance in less than 5 minutes?
Yeah. My interpretation of it, and again, from very uneducated guess, is, hey, if you don't want to recompile Linux to have something, that's when you use eBPF. Or for other audience, sometimes people ask me, hey, what should be eBPF? And I sometimes give them the answer, hey, do kubectl get DS, daemon sets. Those are probably your best candidates for eBPF, right?
There's a lot of truth in that. I think, if we're using daemon sets to instrument every single node, that quite often means we could be instrumenting that. I wouldn't necessarily say everybody should rewrite their instrumentation or their user space applications in the kernel. But if you want really high performance, if you want, the ability to observe events that are happening in the kernel and a lot of interesting things like opening files and sending and receiving messages and accessing memory and changing permissions. All of these things happen in the kernel. So it's a great place to observe them. A lot of those kind of daemon set tools might be things like logging and tracing and security tools. They lend themselves really nicely to being implemented in the kernel. And if you're going to write something in the kernel, eBPF is a great way to do it because it's safer and more easily deployed than rolling out a kernel module.
In the context of containers and Kubernetes, how does that work? You still deploy it as a container, and I'm guessing then you do some magic to run it as eBPF or something like that, right?
Yeah, so when you have an eBPF program, it gets loaded into the kernel using a system call, and you need sufficient privileges to be able to load that program into the kernel. But there's no reason why a containerized application can't be given those privileges. And, that's typically the case. You'd often also want to have a user space agent or companion part that, you might have an eBPF program running in the kernel, collecting some information. But when it comes to displaying that information to a user or sending it wherever it is you want to collect that information, you're probably going to have a corresponding user space part to deal with that and kind of extract the eBPF information. So it's a very common pattern for these eBPF-based tools to be deployed, as you say, as a daemon set, and that a container in that daemon set is going to install the eBPF programs into the kernel and interact and configure that program and present you with the information.
How much usage people might have from eBPF without them being software vendors, right? Observability project or networking project and things like that. Is it a type of technology that a normal person should pick up? For one
define normal person.
Okay, you got me there. Yeah, company does applications for end users like backend, frontend, things like that.
Yeah, there's lots of use cases. Brendan Gregg has been popularizing eBPF for a long time, particularly for observability purposes. And he's talked a lot about things like BPF trace, and there's a whole BCC family of eBPF-based tools that you can run on the command line and use to observe the performance of all sorts of different aspects of a system. And, he was originally popularizing that when he was at Netflix and doing a lot of performance work. So I think anybody who's doing particularly highly scaled performance work is probably already using some of these eBPF based tools. And in some cases, they might be writing some programs. BPF trace is essentially a kind of eBPF scripting language, and you can write custom scripts, a bit like you might write scripts for awk or something. It has a domain specific language for BPF tracing. So there are reasons why people might be kind of touching eBPF quite closely, even if they're, in quotes, normal people. But I think for a lot of people, the technology is transparent. It doesn't matter to you that it matters to you that a tool uses eBPF because you're interested in the performance benefits that that's going to give you compared to a user space implementation. But most people aren't going to write eBPF bytecode. Most people are not going to have to worry about things like how the verifier works or how to attach programs with to different points in the kernel. For a lot of people, they really don't need to know that, but needing to know it and wanting to know it can be two different things.
So I'm guessing right now eBPF is in a way differentiating factor. So whomever is having a project about observability or networking or this or that is almost certainly going to put it there. But I suspect, based on what you said, that soon it will become so transparent and common that it will not be even mentioned, right? You will be probably using it through dozens of projects without even knowing that it's there. Like nobody says we have VMs that use hypervisors today anymore, right?
We've certainly seen that changing over the last, probably couple of years. So I'm very involved with the Cilium project. And a little bit of history here. Cilium and eBPF have kind of been developed quite hand in hand. One of the original founders of the Cilium project is also one of the maintainers of eBPF in the Linux kernel, Daniel Borkman. And a lot of the networking capabilities that exist in eBPF today are there because Daniel's essentially driven them because of the use cases that we had in Cilium. For a long time, every time anybody did a talk about Cilium, they kind of had to talk about this eBPF newfangled, exciting platform that nobody had ever heard of and explain why it was a differentiator for Cilium to provide networking and security. Today, I think a lot more people understand that eBPF is this revolutionary platform, and we don't have to kind of introduce that as a concept before we even start talking about Cilium. That has changed, I would say over the last couple of years. And I think a big part of that is because today, most people are using modern enough kernels that they've got access to eBPF capability. Whereas a couple of years ago, not everybody's kernels were really new enough to have the full range of what you need to run some kind of advanced eBPF capabilities.
So basically what you're saying is the hype cycle for eBPF is starting to trail off now.
Well, I think we're certainly at a point where, I hope we're not going to fall into a trough of disillusionment, but we probably will, because that's the way the hype cycle works. We're certainly at a point where there's many, many more eBPF-based projects. It feels like almost every day, I see a notification about another eBPF-based tool or a vendor who's started using eBPF. So it's certainly being more widely used by projects and vendors. And I think there's still a lot of excitement to be found. I think there's still a lot more innovation on top of eBPF to come. So I wouldn't want to say the hype cycle's over, but I think we are certainly seeing this kind of proliferation of projects, some of which will be amazing and some of which will be kind of disappointing, because that's inevitable when you have a huge range of projects.
So you use the word innovation there. I want to go back to something you said a few minutes ago when you were setting things up. You used the word verifier. What the heck is a verifier in all this? Because I've been listening, I've been reading, and it's like, where did that come from?
The verifier is probably the fundamental thing that makes eBPF better than writing kernel modules. So when you write an eBPF program, we typically write it in either C or Rust, and it gets compiled into these eBPF bytecode instructions. You can, in theory, write those bytecode instructions by hand, but as a human being, I would rather write in something like C. The compiler emits this bytecode, and then that's what gets loaded into the kernel. And it goes through the verifier sort of as it's being loaded. And the verifier analyzes that set of bytecode instructions, makes sure that it's going to be safe to run. So it analyzes all the possible paths through that program. It makes sure that there's no dereferencing of null pointers, that all access to memory is safe. There's a limited set of functions that you can call from inside a BPF program, and it depends where it's attached. So the verifier will check for that. It will check that, let's say you're looking at a network packet, you can only look at that network packet. You can't look at memory sort of outside the bounds of where that network packet is held in memory. So the verifier is doing all these checks to make sure that the program is safe to run and that it's going to run to completion. It will check that there's no non-bounded loops. So it knows that this program won't crash the kernel. And that's a huge differentiator compared to loading a kernel module, because however well-tested code is, if a kernel module does crash, it's going to be a bad day in the office.
Well, it seems like a verifier would help out in loading anything. I wish we had a verifier for all of our higher level languages.
That would be really interesting, actually. I think one of the criticisms that people used to have about eBPF, and it's still true on older kernels, is that the verifier could only handle a relatively limited size of program. It could handle, I think it was 4,000 instructions. That limit is now raised to 1 million. And there are other things that you can do to link BPF calls together. So you can call from one BPF program to another, each of which is verified separately. So each of which can have this 1 million instruction complexity limit. So it used to be the case that people would say, well, eBPF, it's, all well and good, but you can't do anything very complicated with it. I think that assumption is now false, because you can do a lot of really complex programming, but I don't think it means that the verifier is an all-purpose tool for every program, every high level language. There's also a lot of restrictions in what you can do in eBPF, that it's always single threaded, for example. So I think trying to generalize the verifier to higher level languages might be quite a challenge, kind of interesting challenge. I'd love to know if somebody does it.
Well, it seems to me if you have 1 million instructions, just because you can doesn't mean you should.
In terms of writing complex.
Yeah. Should we have complex? I mean, there's probably a few that should be complex, but as developers, our, I guess, initial lean is to always make things complex, whether we want to or not, right? Just because that's what we do.
Yeah. And it's certainly true that you can write bad eBPF code just like you can write bad any other kind of code, inefficient, overly complicated. There's certainly there's scope for people to write good programs and bad programs, like any programming language.
Based on what we were doing last, 10 years, eBPF sounds almost the opposite of what we were trying to do in the past, right? Since emergence of containers, there was a lot of focus how to prevent anything from touching kernel in any formal way, right? Hey, if I ever see sockets mounted or volumes mounted to anything, you're gonna get fired, right? Was mantra in companies in a way, right? And now we're going back actually to that's not such a bad thing in a different way, obviously, right?
You absolutely have to trust your eBPF programs. And I think that's why the pressure to not have anything that touches the host from containers, it often comes from a security concern that if you can get at the host, then, what are you going to break? What are you going to, where are you going to traverse to? And on the host, what other containers are you going to try and compromise? Now, with eBPF programs running in the kernel, they have access to every single process that's running on that machine. That's kind of, it's the very definition of the kernel. The kernel is managing all of those processes. So if we do customize the kernel by using an eBPF program, we have to know that eBPF program is safe to run. We shouldn't be allowing just anybody to run eBPF programs ad hoc on our systems. It's the equivalent of giving people root access. So we do have to be a bit careful about what we're doing with eBPF. But I think, those things like, do we want to see containers mounting sockets, for example? Well, the kernel is the ideal place to have instrumentation to say, is anybody opening sockets? We can trap that very easily with an eBPF program and have policies that could be custom policies, because we can have programs dynamically loaded into the kernel to manage these policies and make decisions about whether that socket is okay to open or not. It's one of the benefits of eBPF is having this all-seeing perspective on everything that's happening across that whole machine.
That level of trust puts newcomers in a difficult situation, I'm guessing. Like right now, everybody knows about Cilium. It's a well-known project and so on and so forth. But I'm guessing that in early days of Cilium, you probably had that trust issue with potential users, right? Kind of, who are you and why would I let you use eBPF in my system, right?
I wonder whether the sort of more recent concerns about things like supply chain security, everybody is aware of that now, but maybe a few years ago, people were a bit less, thoughtful about things like, do I really know where all of this code has come from? Yeah, I mean, it's a totally legitimate question. We should be checking where all of our software comes from, and software that we run in the kernel, even more so. Very, very important that we don't let random eBPF code into our systems.
in what position that puts existing projects, right? I see a lot of eBPF, especially lately, but that's all related, from what I've seen, to new projects that are starting from scratch and saying, hey, eBPF is a choice for my project, which is whatever it is, right? How difficult would it be for somebody who did not start with eBPF to transition? I'm guessing far from trivial, right?
As a user of a program?
No, more like a vendor. Let's say that I have an observability tool, X, whatever that tool is, and it's running in whichever way it's running, but it's not eBPF, right? I'm guessing for those projects, that transition to eBPF would be complicated, to say the least.
Yeah,
right?
I think so. eBPF programming, it is essentially kernel programming. And I think if a team, a company has built up a ton of expertise building things a certain way in user space, they can't magically overnight flick a switch and have kernel knowledge. Now, maybe they've been implementing things as a kernel module, so they do have some kernel knowledge and they can transfer that to running in eBPF. But it's still, there's a learning curve. We have seen a few projects who have made that transition. Falco comes to mind as somebody, they started as a kernel module, and it's still, I think the default is still to install Falco as a kernel module that will instrument various security events. But they also have the option to do it using eBPF. So there are cases where people have done that, but I think like any kind of organizational change, if you have a large team doing things a certain way and you want to change to steer the ship in a different direction, that's inevitably going to be a bit tricky. So and there's so much power that you can get from starting some really powerful eBPF based projects that have started from scratch and not been translated.
So if we're building our eBPF programs in a certain way, using your words, what is the right way to do that? I imagine this is probably like the first 3 chapters of the book.
So there are lots of different component parts to writing an eBPF program. I mentioned that, you're going to write your code probably in C or Rust and compile it to the bytecode. You're going to have some user space code that you have a greater choice of languages, because today only the Rust and Clang and GCC compilers support compiling to the eBPF bytecode as a target. But for user space, there are dozens of languages, not all of which have SDK support for interacting with BPF programs. So you might choose, I'm going to use Go because there's a great eBPF language, or Rust. Again, there's support for user space code. There's options in Python as well. Several, and of C, of course. C is the kind of, I guess, grandfather of all eBPF programming languages, because so many people have a long history in the kernel, so they're used to writing in C, and they naturally turn to C for the user space part as well. So you have a lot of different language choices. What I did in the book is I've tried to walk people through some of those different choices, and I've started with Python because the Python framework that's called BCC makes things very easy to get started. And there are so many different concepts that you need to get to grips with, like, we've mentioned the verifier. We have to think about where we're going to attach our program. We have the user space part and the kernel part to think about. We have something called maps, which is data structures that we use to share data between user space and kernel. All these different moving parts, if you like. BCC is a very friendly way to start introducing yourself to these concepts. But I wouldn't necessarily recommend it for a production project, largely because of a really interesting thing called compile once, run everywhere. So if you're writing an eBPF program, it is going to interact with the kernel, and the kernel data structures can change from one version to the next. And compile once, run everywhere is a really quite complicated mechanism to enable you to write an eBPF program on one kernel and have it dynamically adjust itself, so that if I send my program to you and you're running on a different version of the kernel, my program can adapt itself to the layout of data structures on your version of the kernel. It requires support in the kernel, it requires support in the compiler, it requires support in the user space libraries. It's really quite complex, and that if you want to have a production quality eBPF tool that you can distribute more widely, you probably want to build it using this compile once, run everywhere support. And there's only so many user space SDKs that have support for that today. Cilium's eBPF library being one of them. If you're using Go, in Rust, there's a project called Aya that has support for it. Then if you're using C, there's a thing called libBPF, which all of those are your choices today if you want to write compile once, run everywhere.
Oh, you just took away my next question. I was wondering, or thinking that it must be a nightmare to work with eBPF. if your intention is to distribute it to as many operating systems as possible. Okay, so it's less of a nightmare than I guessed.
It's less of a nightmare. I'm not going to say that it absolutely solves every single problem for you, because it's one thing that data structures can be changing from one kernel to the next, and that might be fine. You might only be looking at certain fields that may have moved but still have the same meaning. But if you use a data structure in a version of the kernel, and maybe that field is a new field, and you compile your program and send it to me, and that field doesn't exist in my kernel, then not necessarily going to work. So there is a lot of thought and complexity that goes into making sure that programs can not just kind of be adjusted automatically, but also will actually function correctly in different versions of the kernel. It's and there's also things like different levels of eBPF support that different kernel versions have. So if you maybe an older kernel might not have a certain program type or a certain ability to attach to somewhere in the kernel, and you might have to figure out how to cope with that. This is the kind of really quite challenging problem that I think when I first heard about eBPF, I was totally unaware of, and working at Isovalent with all these folks who work on Cilium has really opened my eyes to, the set of problems that they're dealing with is pretty large. This is a pretty specialist subject.
My next question might create a new hype. I don't know yet. Is there some synergy between eBPF and WASM?
Oh, that's a great question. So there's a lot of, I think, conceptual similarities in that. Both of them are talking about running programs in a sandbox, in a safe environment, and this kind of portability idea. Now, I will rapidly get out of my depth with WASM because I don't know that much about it, probably just enough to be dangerous. I think the fact that eBPF runs in the kernel lends itself to these kind of infrastructure tools in a way that maybe WASM doesn't. So I think WASM, feels to me like a really great way to add user space customizations to, the example that I'm probably most familiar with is Envoy Proxy, where people add custom filters and custom behaviors using WASM. I'm going to say plugins. I'm not sure if that's precisely the right term, but customizing the way that their Envoy proxy behaves by writing WASM and knowing that it's isolated safely. I think while they have some conceptual similarities, I'm not sure that they really lend themselves to solving the same kinds of problems. But I would love to be proved wrong if people have, really great ideas on, or how they can interact together. I'm sure there is innovation to be made, and people will come up with amazing ideas of how these two worlds can intersect.
It's interesting you bring up the isolation. You've already talked about it from the kernel perspective, but safely isolating. That's really a key part for any code that we write, period, right? That's how we should be thinking is, okay, what is the blast radius from whatever I'm writing? If it was to blow up, how bad is it?
I mean, that's absolutely true, and speaks, I think, to, needing to know that your eBPF code is coming from somewhere that's, so the verify goes a long way to making sure that it's not going to blow up, though. So things can go wrong, but they're unlikely to bring down the whole machine. If we're talking about security issues, you really need to be confident of the provenance of your eBPF code.
Then how do we figure that provenance out?
I think a lot of the work that's happening in supply chain security helps a lot with this. So if your eBPF tool is being distributed, like we talked before about, it's deployed as a daemon set, so it's coming as a container. We can use a lot of those SBOM and supply chain security mechanisms that people are using in general for containerized applications. There is a really interesting technical challenge that's being worked on by folks in kernel developers at the moment around the eBPF programs itself. So everybody likes the idea of signed programs. We want to get a piece of software, we want it to be signed, and then we have confidence that is the software that we think it is. And you might think you could do the same thing with eBPF, but you remember I talked about compile once, run everywhere, and how it adjusts the program as it's being loaded into the kernel, and how it's got user space and kernel side aspects to that. And that makes it very hard for the kernel to check a signature, because the program has changed between it arriving on the computer and it actually arriving in the kernel. So it's very difficult to have a signature that you can just verify over that program, knowing that somebody is going to deliberately manipulate it to make it compatible for that kernel. So there is work being done to solve that problem and provide the ability for eBPF programs to have a signature that can be verified.
Yeah, that was when you were previously talking about that adjustment. I didn't want to say anything, not sound silly, but some bells were ringing in my head, kind of, what do you mean you can adjust? You just got to the point that I somehow trust you to run in my cluster. And now you're adjusting to something that only you know that you're adjusting to. It sounds.
To be fair, the programmer probably doesn't know what's being adjusted. It's all in the user space library kind of matching differences. But what happens is your eBPF program comes with a set of definitions of what were all the data structure layouts where this was compiled. And your user space library kind of compares that with what's the layout of all these data structures here in this particular kernel where I'm running. And you get these kind of relocation instructions that end up moving things so that what you end up running is not the same necessarily as what you received over the wire.
Maybe the problem then is with terminology, right? Because when you say we're going to run in your servers and we're going to adjust, sounds like spyware to me. That's how it sounds.
It's definitely something that the kernel community have recognized as needing a solution. It's just not as simple as compiling a user space application.
I want to go back to what we were talking about earlier, the normal developers. The way I define a normal developer, at least in these days, is a person doing a business application. It makes near zero sense for that type of developer to do anything. However, a shared services or a platform team, that seems like the people that would actually be potentially writing eBPF type things because they're having to bake images, whether that's a container image or actually a machine image. And having all of these things in place, these things being eBPF programs, is a huge gain not only for those teams, but everybody consuming it and therefore the organization.
Yeah, absolutely. And I think we can, take lessons from history. We used to have sysadmins who knew about how to configure machines and set up the underlying machines on which developers' applications would run. And we've always had this kind of split between people who understand how the underlying system fits together, and maybe it's split into different people who know about networking and security, and then the business application developer who really shouldn't have to worry themselves with what hardware is this running on. I think, we've, with cloud native, with the whole DevOps movement, we've got many more sort of layers in that kind of stack on which the business application is sitting at the top. There's lots of different complexity, lots of different areas in which people can specialize. I think a lot of platform teams probably won't write their own eBPF code either, because they'll be using projects, they'll be reusing existing tools. There's I think they will be using eBPF based tools, whether that's large scope projects like Cilium or smaller CLI tools like some of these BCC tools, things like OpenSnoop or ExecSnoop, all these things that can show you details of specific operations across a machine or even across a cluster. There's a really interesting project called Inspector Gadget, which takes these eBPF-based tools, command line tools, and essentially makes them Kubernetes ready. So you can run OpenSnoop and get information about every file open that happens on your system, but in a Kubernetes environment with the information about what pod was involved and what node was it running on, that kind of identity information as well, which is, I think, really, really useful.
Yeah, I feel that that's a trend that's been going on for a while now, that, if you go back in the past sufficiently, every major company had at least one person who knew how to compile its own Linux distribution and run it on servers and stuff like that. I feel that now we're having more chasm between, low-level people and higher-level people, that there is simply no need anymore for such low levels in a company, right? You will be using tools that are written on lower levels instead of going that deep.
Yeah, I think it's one of the reasons why Kubernetes has taken off so much. I'm not somebody who thinks that Kubernetes is the right hammer for absolutely every nail, but I think the fact that you can have a sort of abstraction that you can use for running those business applications that's at least theoretically entirely independent of the infrastructure that it's running on. It shouldn't matter to a business developer whether their application's running, in AWS or in Google Cloud or on-prem or wherever. It can use the same kind of Kubernetes YAML essentially to be defined, and I think that's not needing to have quite so much specialism. I mean, somebody still has to understand how those servers are deployed, but a lot of that is now outsourced to public cloud, and the quote low-level expertise becomes how do we install Kubernetes in our platform? How do we connect our Kubernetes platform, our different clouds together, and so on?
That question, if you ask a question like 15 years ago, what is the operating system you're running on? There was hardly a person who could not answer that question. And now, in managed services, Kubernetes, if you ask that question, I bet that significant percentage of people will say, I don't know.
Yeah.
I don't know it's some Linux. I know that much. It's not Windows. That's how far I go, right?
Absolutely. And, in some cases, it might be a variety of different underlying distributions of Linux. It might have, maybe it's running on, a container OS in the cloud, and it's running on just a RHEL or Debian or something on-prem, and it doesn't matter to the application.
Well, the book is Learning eBPF. It's from O'Reilly.
Wait. Did we just did a big disservice to your book, Liz? We discussed so heavily how normal people shouldn't go into eBPF. We reduced your audience.
I genuinely think most people won't need to write their own eBPF programs, but that doesn't mean to say it's not interesting to understand, to get a mental model of how it works. It's similar to, I'm going to say my most popular talk that I ever did was how a container works. And I illustrated that by writing a container from scratch in a few lines of Go. I do not think that anybody should be writing their own container runtimes from scratch, but it was more about building a mental model. And I hope that sort of similar approach of, you don't need to know all of the details, but you might find some of the details really helpful to just get an impression, get a sense of how eBPF works. And for some of us, certainly for me, getting my hands dirty and actually trying it out gives me a much stronger sense of, okay, I have a good sense of what this really is, and I can make sensible decisions about whether it's appropriate to use it or whether this tool that claims to use it is sensible, or so for the people who are curious, you don't have to think you have a business need to write eBPF applications, I think, to be interested in how it works.
Okay, so can I talk about the book now, or now are you going to throw me under the bus again? So again, the book is Learning eBPF. See, finally, I can say the phrase. What is it with 4 letters? Okay, we can say WASM. We don't say WASM. How can we say eBPF? Like how we say WASM.
Yeah.
Is that another book?
Yeah. Attempts to turn that into a pronounceable word have thus far failed, I think.
We can blame BPF for that. Actually, we can blame PF for that. Actually, PF is easy. Never mind. I don't know why I went down that route. Anyway, Learning eBPF from O'Reilly. It is available now wherever you get your books. Try to buy it from a local bookseller if you still have a local bookseller before you go to one of the big ones, if it's available. Or also you can just get it directly from O'Reilly, right? Because is it part of their package subscription or whatever?
Yeah, if you have an O'Reilly subscription, you can get it through the O'Reilly site, yes. And you can also, for the cost of your contact details, download it from isovalent.com.
Oh, for quote unquote free.
Exactly. The cost, the price is your contact details.
No, but since significant number of companies use Cilium, then you already have their details. So there is no loss there.
Lots of people are using open source Cilium without telling us who they are.
Okay,
A lot of
fair
people
enough.
have told us who they are because we have a really nice list of, adopters in the adopters file. So, I totally encourage people, if you're using Cilium, we would love to know. We'd love to see you add yourselves to the adopters file and hear more about, your use cases. Even if you have no intention of using an enterprise version, if you're just using the open source Cilium, I think that's wonderful.
So all of Liz's contact information is going to be down in the episode description. But Liz, what is the best way for people to follow you, contact you?
I am on pretty much every social media out there as Liz Rice. Who knows what social media platforms will be available by the time this podcast is actually released. But I try to grab Liz Rice everywhere.
And watch for Liz at all the big conferences. Liz, thanks for being with us today.
Thank you for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.